This is our third video for 6.4. So we're going to finish this last little section. So we already talked about the fundamental theorem of calculus, which we have right here, which says if I take the integral from a to b of f prime of x, I can integrate f prime of x, find f of x, and I plug in the upper limit f of b minus f of a. Well, from that, if we take this f of minus f of a and I add it over to this side, I end up with this. I end up with f of b equals the integral of f prime of x from a to b plus f of a. So really we're just using the fundamental theorem of calculus. We're just rearranging it. This is a really, really common problem on the AP test there. So when I know how to do, you're going to use this when you see this. If it gives you the derivative, I've got the derivative. It gives you one point on the function. Okay, notice, and then it wants you to find another point on the function. Whenever you see that, you got to think, hey, it's a starter plus accumulation method. Okay, so we're going to go like this. I'm trying to find f of 2. So I'm going to say f of 2 equals the f of a, f of 0, plus, and this is really important, is the 0 has to be the lower limit, whatever is on the same side. The 2 has to be the upper limit of 3x squared plus 3. Okay, so I'm just plugging in this formula up here. So there's the point I'm trying to find when trying to find f of 2. I know f of 0 right there, and I can find this definite integral right there. Okay, so let's work this out. That means that f of 2 is equal to f of 0. Well, right here it tells us f of 0 equals 4, so 4 plus, and I need to figure out what this is equal to, so let's integrate it. So that would be 3x cubed over 3 plus 3x, and I'm evaluating it from 0 to 2. So I end up getting 4 plus, that would be x cubed plus 3x. Again, I'm evaluating it from 0 to 2. So 4 plus, if I plug 2 and 2 cubed is 8. Plug 2 in there, it would be 6. It's supposed to be a 0 down there. Minus, if you plug 0 in, I get 0, 0, so minus 0. I add that up. So 4 plus 8 is 12, plus 6 is 18. So f of 2, the answer for that one, f of 2 is equal to 18. This really is just knowing the formula. The tricky part, well, knowing the formula and knowing when to use it. So again, what gives it away? Whenever it asks you to find f of something, and it gives you another point, and it gives you the derivative, that's what's going to kind of, that's going to let you know that this is the method we're going to do here. Okay, let's try number 15. So if an object's velocity, v of t, equals 2 to the 3t squared minus 5, and the position function, s of 1 equals 8, find s of 2. So just so you know, s of 1, right, is the integral of the velocity, or the velocity is the derivative of s. I'm trying to find s of 2. So I'm going to come over here. I know that s of 2 is equal to, I take what s of 1 plus the integral of its derivative, which is 2 to the 3t squared minus 5. We're going from 1 to 2. Okay, so s of 2 is going to be equal to what s of 1 equals, which is 8, plus, okay, now I've got to integrate that. I don't have any way of doing that by hand, right? If I wanted to do it by hand, I would have to know. I would have to have the derivative of the power on the outside, right? The power is the inside, so I'd have to have a 6t. Well, I can get a 6 there, but I can't get a t there. So we're going to do this in a calculator. So grab a calculator, and we're just going to do that integral from 1 to 2 of 2 to the 3t squared minus 5. Why don't you go ahead and pause the video and grab your calculator and take a second and use remember you'll math, go to the function interval, okay, and take a second to figure out what this is equal to. Then we'll come back and we'll finish up here. I ended up, and then when I did it, it ended up coming out to be 16. Oops, doesn't want to write there. I'll put it, let's try it down here. So it ended up being 16.502. 8 plus that, which means S of 2 is equal to 24.502. So this is just, again, it's just a variation of the fundamental theorem of calculus. All we're doing is solving for f of b. But you just got to know this formula. If I'm trying to find the value of a function at a certain number, and I have the value of the function at a different number, and I have the derivative, you can always use this method to find it. Okay, that should be it for 6.4. We're finally through. Thanks, guys.